Yeah,
Yes.
because so now I will be attending from Monday to Thursday.
Monday to Thursday and then on weekends, right?
So I'm not sure about weekend. Maybe I can only attend one class. Maybe on Sunday. I can do on Sunday because I have other job as well. I can't
Oh,
do the whole week.
okay, okay, okay.
Yep.
So we'll do the session on Monday to Thursday, 1 hour session, and on Saturday we'll do a
And one Sunday, I guess.
yeah, on Sunday, sorry. On Sunday we'll do a 2 hour session. And if you are available on Saturday too, just let me know.
And if I'm available on Saturday, then I will let you know as well.
Yeah, sure.
Yep.
Okay.
So now from Monday to Thursday, it will be 1 hour or 1.5 hour.
1 hour. Because we'll start at 1 and I have another session at 2:15. So
So
1 hour
what?
15 minutes.
1.5 hour.
No, 1 hour 15 minutes maximum because another
Okay.
session
Yep.
starts at 2:15.
Okay. No worries.
So we were talking about IP addressing. In that we saw two types of IP addresses.
IPv4 and IPv6.
Right. And IPv4 was 32-bit address
32-bit address.
and IPv6 was
What? 128.
and this IPv4
Uh,
address they
uh, can I send a call
yes.
for just 1 minute? Just 1 minute.
Okay.
Yep.
Okay. So these two types of IP addresses were there. IPv4 V6. V4 was a 32-bit address and V6 is 120.
Yep.
And this IPv4 they divided it into 4 octets containing 8 bits each.
Yep.
Okay. And we also saw some examples like anything.
Yep.
And another 172, 25, 32, 10, 1, 2, 3. These are IPv4 addresses, examples of that. In decimal form, you can say.
Yep.
If you want to convert it into binary, let's say I want to convert this into binary. So for that,
Yep.
we are going to take the first octet. And how many bits are there in the first octet?
Um.
Each octet have
Um.
8 bits, and there are 4 octets in total. Okay, so that will sum up to 32.
Yep.
And so if you want to convert an IPv4 address from its decimal form to binary, in that case, you need to first remember that if binary is 0, that means it's off. If it is 1, then it is on.
Sorry,
And
can you tell me again, off and on, the
yeah, like
you
binary number will be like this 0, 0, 1, 1, and all this. So if you convert it into decimal, in that case, you will consider this 1 as on and this 0 as off.
Okay.
Okay. Then what you need to do here is just start from the right hand side of the first octet and put values starting from 0, then 1,
1,
2,
2, 3, 4,
7. So 8 bits are there, and starting from the 0th bit, it is going up to the 7th bit.
yeah.
Okay. And for now, we are talking about only the first octet. And now you need to calculate the values after putting these bits number in power of 2. So we also calculate that one. 2 power 6, 5, 4, 3, 2, 0. So starting from 0, it will be 1. Then
1,
just double it.
then 2, then 4, then 8, 16, then 32,
Right.
64, and 128.
64 and
128.
128. Okay.
And sorry, why would we? I mean, multiplying 2. I mean, why we can't? Or is this the formula of calculating?
Yeah, this is the formula while we are converting it to the decimal.
Okay. Yep.
Okay. So, and let me write these values here. 128, 64, 32, 16, 2, and 1. So now if we want to convert 192 into binary, in that case, you need to check these values, like how by adding what values, which of these values we get 192. So we saw that if we add 128 plus 64, we'll get our desired result. So you just need to turn on these 2 bits. So the answer will be 1, 1, and the remaining 6 bits as 0. So 1, 2, 3, 4, 5, 6.
Yeah.
If you convert 192 into binary format, this will be the result. So just like that, convert the rest 168, 43, and 17 and tell me the result for that.
Sorry, I didn't get this first part.
Like
You just
just a minute. What we need to do here is you need to check these values, the resultant values we got here, by putting those number of bit on the power of 2. And now you need to check which of these values, if we add them, we get 192. So if I add 128 plus 64, I got 190. So just turn on those bits. Like 128 was on 7th bit, so turn that bit on.
Yeah.
And 64 was on 6th bit, so also turn it on. And the remaining bits will stay in off state.
Okay. Get it.
Just like that, convert 168 into binary.
So that would be um
Hello.
Yep. Yep. Yeah, I'm trying.
Okay. Yeah.
So that's 128 plus 32 plus 8. That's a 1, 0, 1, 0, 1, and 0, 0.
101, 01, 000. Thirdly, it will be for 43.
43 is a so 32 plus 32 plus 8, so 32 1 8 1 and 2 1 and 1 1.
So 101, 32 plus 8, 40, 42, and okay.
Yep.
And the last one.
16 and 1, so 0 0 0 1 0 0 0 1.
So like this, if you ever need to convert IPv4 from decimal to binary, you can do that. So what will be the maximum number that can come in any of these 4 blocks? You just need to add all these values, starting from 128, 162, 54, 32, 16, 8, 4, 2, 1. So if you see, the IPv4 address will never get a value which is above 255.
255.
So the minimum is 0 and the maximum is 255.
Yep.
So now, depending on the range or the value in the first block, they created multiple classes for that.
Yep.
And let's talk about those classes now. So types of info. This one is class A. Class B. B. E. And E. So they would divided it into 5 classes. For the first one, it starts with all the bits zeros.
Yep.
The next one, it starts from here.
Yep.
So if you convert these values from binary to decimal, binary to decimal, what will we get? First, all the bits are zeros. So then we don't need to add anything. That means
0.
0. Then here the 7th bit is 1. What is the value in 7th bit?
128.
128. Then starting 2 bits are off, 2 bits are on.
Then
28 plus 64.
128 plus 64 and 192. So that's 64 plus 128 plus 224.
And last,
That's 240.
so if we write the range, the class A can go up to, so it can go just one below than class B. Class B is starting from 128, so it can go up to 127.
Yep.
Similarly, the class B can go up to 191 because from 192 class C started.
Yep.
Then here 223.
223.
After that, just hold on a minute.
240.
Just a minute. The call is coming.
Yep. Yep.
Sorry about that. Okay, so then next is class D. It can go up to 239, and the last one is it class E.
255.
Right. So out of these, some we will not be assigning on the systems. We will not be using while we are creating a network. Like the 127th one, it is mainly used for loopback address. It is used for pointing out to your own system only.
Yep.
This 0th will be used for internet. Like if you want to point out to all the addresses at the same time, we will be using the 0th block. Last one is 255, that is used for broadcasting purpose. Okay.
Yep.
And in our case, in companies and systems, we will be using these three: class A, B, and C. If you try to assign an IP address which is higher than class C, you will not be able to do it. Right, let me show you
And
here.
why is that?
Because those IP addresses of class D and E are used for research purpose and multicasting purpose in routers. So show available. Like if we try to change the IP here in properties, IPv4, and if I assign an IP address which is higher than 223, like I'm gonna write 235. So we got the error that it is not a valid entry. Please
Yep.
specify a value between 1 and 2 to 3. Okay. Only class A, B, and C will be used to create our networks.
Yep.
And then again, what they did, there were 4 octets in an IPv4 address. Out of those 4 octets, they said that class A have a single network octet and the remaining 3 are of host.
Yep.
So a network octet will have multiple hosts. Okay. For a single network, the host bit can change. But if the network bit is different for 2 IP addresses,
Yep.
they are of different networks and they will not be able to communicate with each other by default unless
Yep.
you attach a router there. Okay.
Yep.
In class B, we have 2 network blocks and 2 host blocks. In class C, we have 3 network blocks and a single host block. So how many? Yes.
Can you can you explain that again?
Yeah, just a sec. Let's write the next bits first. So here the network bits will be a single network block is there, and in each block, in each octet, how many bits are there?
Sorry, pardon? I didn't get the question.
How many bits are there in each octet? In each blocks which we divided into IPv4 classes, how many bits are there in each of them?
You mean that we just one that we 1, 2, 3, 4 that we just
Yeah,
numbering?
just numbering.
So I need
So
to
in like
so
here,
that's
just see
8.
here, right? So in each octet we have 8 bits. In each block we have 8 bits, and here one block is of network block. So how many network bits will be there? 1 into 8. That means 8 network bits. How many host bits will be there? 3 host blocks are there, and
Yeah.
each block have 8 bits. So that will be 24.
24.
Okay. This tell me the network bits and host bits for class B and C.
Um, so that's 16
Right.
and 16,
About
24 and 8.
24 and
8.
so what will happen by dividing these blocks here, these network and host block? The range of class A is starting from 1. Correct?
Yep.
In the first block, the value can go up from 1 to 26. Not more than that. But in the remaining 3 blocks, which are of host here, the values can go from 0 to 255 0 to 255, 0 to 255 in each of them. Here to here, this two. Okay.
Yep.
So if someone says how many networks are available in class A, so networks are available from 1 to 126. But how many
Yep.
hosts are available in each network? So you need to calculate this value. Just like in clock, we see the time starts from the right hand side. Like first of all, the seconds. It can go up from 0 to 59.
Yep.
Once it hits again 0, then the minute one will change. Okay.
Yep.
So just like that, if we talk about here, let's say it is starting from 1000. Next will be 1001,
One.
1002. In the last block, the value can go up to, once it has reached the maximum value, then the second column from the right will change value 1.0, and again it will go up to 1.1255 and keep on going up to 255.255.
Yep.
Then we still have another host block in which the value can change. So in that case, it will start from 1 and it will go up to this. So this is a network of class A. Just like that, if in the network block the value changed. Sorry. So in the network block, if the value is different, it could be anything from 1 to 126. They will not be able to communicate with each other by default until unless we connect a router between them. Okay, because IP addresses of different network cannot communicate with each other. And the first IP address from this IP, from this network, and the last IP address from this network. We cannot assign these two IP addresses on systems. Why? Because the first one is called network address, which is used for identifying that network.
Yep.
Last one is called broadcast address for that network. So if you want to broadcast a message in that particular network, you will be using the last one. So you cannot use these two. Other than these, all the remaining IP addresses you can use here from this network. Okay. So this is for class A. Wait. So next, let's write number of IP addresses inside a single network of a class A, class B, and class C.
Yep.
So for that, you can directly use this formula 2 raised to the power number of host bits. So what will be the answer? Calculate. Number of host bits in class A is
3. So that's
4 to 1 crore 67 lakh 27,216. If you talk about class B, it will have 2 power 16. it will go up to 65,536. And if we talk about 2 raised to the power 8, it can go up to 256 IP addresses.
Yep.
Okay. But out of these, how many are usable? These are the number of IP addresses in a single block, but how many of them are usable?
Will only which are less than 255.
All will be less than 255, and not any, no IP will go above 255. But still we will get this many combinations because it is starting from 1 and it will going routing up to 255. So in the last block, the values can come from 0 to 255. Like the network block will remain same, but the remaining 3 blocks can change the values. This block we can get 256 combinations. In this block 256, in this one 256. We just need to multiply these 3 values. If we do that, 256 into 256. So we are getting this many IP addresses inside a single network of class A. How many networks are there? 126 networks. So in only in class A, you will get up to this many IP addresses. 211 crore 39 lakh. Only in class A.
So that's the number of different IP addresses that we can use in class A network.
Yes. Different IP addresses in class A. Total number of IP addresses which are available in class A. If you only want to talk about number of IP addresses in a single network of class A, that is this one, 1 crore 67 lakh 77,260. And as we saw here, out of each network will have these 2 values. Each network will have a network address. It will have a broadcast address. You cannot use those 2. So the usable IPs in a single network of class A, B, and C, you just need to minus 2 from the total IP.
2 from the total, yep.
It's 214 for class A, 534 for this one, and 254 for class C. Okay. Number of bits to IP in a single network. And this one is our usable IP in a single network. Next one was range. Okay.
Yep.
So depending on how many network bits are there, or you can say depending on how many network blocks are there, another value came in existence that is called the subnet mask. Whenever your network team is providing you a subnet mask, or if you are working as a network admin and you want to provide your system admin with a particular IP address to assign on the system, you need to provide this net mask value.
Yep.
Okay. So subnet mask in binary and in decimal, we'll see both. First of all, let's check the decimal subnet mask. And the simplest way to remember is check the number of blocks, network blocks in class A, B, and C. How many network blocks are there in class A?
1.
1. So write 255 one time and the remaining 3 blocks as 0.
0.
So this is the subnet mask of class A. For class B, how many network blocks are there?
2.
2.
But why we give it the value of 255?
We will get that point when we convert the subnet mask into binary value in a binary format. What is subnet mask telling you? It is telling you the number of network bits available in your network.
Yeah.
If you write, let me scroll first. How many network bits are there in class A?
It's 24.
Those are host bits. The network bits, one network block is there in class A. That means 8 network bits are there. Okay. 8 bits of network, the 24 bits of host. That is predefined. It will never change for class A, B, and C. So you just need to write 1 8 times here. If I write 1 here 8 times, 1, 2, 3, 4, 5, 6, 7, 8. And the remaining bits, remaining 24 bits or the host bits, you can say you will need to write it as off. So 0, 0, 0, 0, and again. So this is the subnet mask in binary format of class A. What about class B? What is the number of network bits?
16.
16. So write 1 here 16 times.
1,
1, 2,
16
3,
times.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the remaining
Is a whole host
zero.
bits.
Right. Then the third one, how many network bits are there?
24.
24. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 18, 19, 20, 21, 22, 23, 24. The remaining are 0. So just by checking the subnet mask of the IP address, you can tell how many network bits are there, and in turn you can tell how many network blocks are there. And this, what we are discussing right now, is a classful IP addressing, where we will be using the classes. We will be following these net mask values. But later when you do the subnetting part, the net mask value will change, because the number of network bits in while you do the subnetting will not remain in these three, always in these three. It could be 10, it could be 23, it could be 27, depending on your scenario. Okay. And the last value that we need to discuss here is called CIDR. You got the value of your subnet mask. Through that, you can calculate the CIDR value. Just count the number of ones, continuous number of ones in your binary subnet mask. So for class A, it is 8. So put that value after a slash. So CIDR of class A is /8. Class B is /16 and /24.
What values is that?
Classless inter-domain routing. CIDR value. So sometimes you will get an IP address, or you will provide the IP address to your system admin like this, that you need to set this IP address on the system. The subnet mask is 255.255.0. The gateway entry will also be there. 68.46.254, and it may be possible a DNS entry is also there. So you will be providing the IP address to your system admin like this, or you will be getting the IP address from your network team. Or they can provide you the same IP address like this. So gateway and DNS both have the same value. So it's up to you. You should be able to understand what this 24 means, or if it is written this like this, you need to follow that. Okay.
So when you convert that subnet mask value to binary, and you have written the network bits value as a 111 and the host as a 000. So I didn't get there because it's so much to consume. It's confusing now.
Like network bits of a network of class A, B, and C, they will remain same. They are predefined and they are same for now, and they will remain same in the future too. Okay. And the subnet mask value of those three classes are also same. I'm just telling you the way to remember those values. Like how can you remember them? You will not be changing the subnet mask for class A, never. If someone tells you, if someone asks you that what is the subnet mask of class A, it is 255.0.0.0. If he asks you to, if he provide you this value, and he tells you that this is the subnet mask, you need to tell the class. So if you convert it into binary, into decimal, and you know that class A have a single network block, you will be able to identify it. So this subnet mask is used just to identify like which class of network you are using. Like if I do IP config here, there is subnet mask with each and every IP address. Okay, and we can tell by checking the subnet mask, like there are 32255s, that means it is of class C. If there were two, it would have been of class B. Like one more point that you need to remember here is IP addresses of same class, let's say IP addresses of different networks will not be able to communicate with each other by default. If you want them to communicate, we need to do routing, or you can say we need to use routers. So by default, they will not be able to communicate with each other. So let me write some values here. Just a sec. Okay. Let's say I have 4 systems here. System 1 and let me just copy it. So 1, 2, 3, and 4. So if I want to connect them directly, I don't need an internet working device. I can just use the LAN cable and connect them one to one. So peer-to-peer connection can be made here without any need of switch hub or anything else.
Yep.
Let's say the IP I'm providing in this one is 192.168.43.25/24. Dot 29/24. And these two systems have so tell me, can they communicate the first two devices and the next two devices? Can they make connection between them? Can we use the ping command to check the connectivity between them?
Uh, because they have different IP address.
They have
So
different IP address, but you need to check whenever we are talking about whether they can communicate or not. First, we need to check whether they are a part of a single network or not. If they are a part of single network, they can communicate by default. And how will we check whether they are part of a single network or not? For that, first of all, check the CIDR if CIDR is given. If
that's
CIDR is
same.
not given, they will provide you with the subnet mask. So one of these values will always be provided to you.
So if the values are same, then they can connect by default. The C, whatever that value is, CRDA.
Sorry. Even if the CIDR value is same, like in the top case, in the first two IP addresses,
Yep.
the CIDR is
Same.
/24. Okay.
Yep.
In the next two cases, in the next two IP addresses, the CIDR is same again,
Same. Yep.
but they cannot communicate. The devices at the bottom, they will not be able to communicate by default. But the devices at the top, they can do it. They can communicate.
So why?
Why is that? Yes. Let's see here. Depending on the CIDR, how many network blocks are there in this IP address, in all of these IP addresses? How many network blocks are there? Hmm.
So
See here. The CIDR we got the CIDR is /24 in the top here. Okay. If the CIDR is /24, that means there are 24 network bits.
And
We are
eight.
going backwards. If there are 24 network bits, that means there are 3 octets of network,
Three
or you
octets.
can
Yep.
say 3 blocks
Three
of network.
blocks. 3 blocks of network.
And as I told you before, the IP addresses of same network can communicate, but different network IP addresses cannot. And for a particular network like this we saw here, if you see this one is the first network of class A. There are only a single network block in class A, and if you see here, the one is remaining constant for each IP address. It is not changing.
Yep.
For a particular network block, the value will remain constant throughout the network. It will not be changed. So if we go back to our current scenario, yeah, the CIDR is 24. According to that, I got that there are 3 network blocks. And for them to be part of the same network, these 3 values should remain same. If they are different, in that case, they will not be able to communicate. Okay, just a minute. So if we see here in the first example, in the first IP addresses, the IP is starting from 192 in both cases. The first block is same, to exclude that one. In the second block, it is 168 in both, exclude that one too. Correct?
Yep.
In the last, it is 43, and here it is also 43. So all the 3 network blocks are same. That means the IP addresses are of same networks.
And they can connect.
They can communicate. If we see here in the next one, 192.168, 192.168. But the third block is different. That means they are of different networks.
So if they have to like communicate, the first 3 blocks have to be the same number.
No, not the first 3 blocks. The network blocks needs to be same, because we will not be
Yeah.
taking the class C IP address every time. Okay, in
Yep.
class B, only 2 network blocks are there. So there we need to check the starting 2 blocks. For class A, the first block needs to match. Okay. Let me let you another example. 001/8 and 002/8 and 001 and 10.00. Now tell me 2 things: the class of that IP address of all these 4 IP addresses and whether they can communicate or not.
Um,
Mhm.
yep. Hold on, just give me.
Yeah.
The above one is a class A network,
Right.
and the below is the last two one is a class B network.
And whether they can communicate or not.
Um, yeah, they can communicate.
Both cases.
Yeah, the first the all of them.
Okay. And if I did this, I removed the cable from the first and second computer and I attached that cable to the fourth one. Now tell me whether this first device can communicate with the fourth one.
Uh, yep, they can still communicate.
No. What is happening here? How will you identify them? Let's talk about that first. First of all, check how many network bits are there.
Yeah, I'm just confused with network bits.
Like here, you can identify the network bits from this CIDR value. CIDR value is the exact number of network bits you have in the network.
So that's a
So in the first case, in the top scenario, the network bits are 8.
8.
Here too, the network bits.
Same as the other one, 8.
But in the second case,
That's
the
60.
16. Next thing you need to check is the, for now what I'm telling you is checking whether they are of same class or not. Okay, because the network bits are same in the top two, the network bits are same in the bottom two, but
Yeah.
next thing you need to check is the network block.
Yeah.
According to this, if network bits are 8, that means only a single block of network is available. Okay.
Yeah.
In the top two examples, one network block and 3 host block. The bottom two examples, network blocks and 2 host blocks.
Yeah, I'm not getting this one network and host block now for these IP address.
For these ones,
Confusing.
okay. Let's say you have a hall here, a big hall. In that, you can place many chairs, let's say, but you divided it into multiple smaller rooms. Let's say 1, 2, 3. And again, and one more time. And so now we have rooms of three different sizes, correct?
Yeah.
And let's say I want to number those rooms, and from the biggest room, let's say, let me change the color for those. The biggest rooms are of red color. Then we have blue, and the remaining are of purple. Okay. So now tell me, if we want to put chairs in all of these rooms, will the number of chairs remain same? Let me number the room 2. This one is room number 1, this is 2, then 3. Then from here 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 16, 17, 18, 19, and so on. Now tell me, will the number of chairs, if I'm putting chairs in all of these rooms, and I want to put chairs in room number 1, and I want to put chairs in room number 10 and room number 20, will the number of chairs remain same in all of these rooms?
Obviously not. This is
This,
the
right?
depending on the size, because they all have different size.
Correct. They all have different sizes. And if I say I have 4% in room number 1, or let's say 4% in each of the room.
Yeah.
Okay. And I want that the person from room number 1 can directly communicate from person from room number 13. Can they do it if they are staying in their room only without the
No.
help of a device? No, they cannot. If they want to communicate, either the people from room number 1 needs to leave their room and go to the room number 13,
Yeah.
or the people from room number 13 needs to leave their room and go to room number 1.
Yeah.
Correct?
Yeah.
So the same thing is happening here. You can understand like this red block is for class A, in which multiple networks are available. The
Yes.
number of those network can go from 1 to 126, and
Yep.
that depends on the network block. Network block is nothing but telling you how many networks are available,
Yep.
and in each network we can place how many chairs? 1 crore 67 lakhs 77,216. So
Yep.
this many IPs are here, this many IPs are here, and the same here. Okay.
Yep.
If we talk about class B IP addresses, there the number of network increased, but the number of chairs in each network decreased
Yep.
because the size is reduced
Because
there.
of the size is reduced. Yep.
If we talk about network blocks now, there are two network blocks. In the first network block, the value can come from 128 to 191. In
Yep.
the second network block, the value can come up from 0 to 255.
Yep.
So the number of networks increased, but in each network, the number of IP addresses decreased.
Yep.
Each room can have this many chairs. Same thing for class C. There are three network blocks. in the first network block, the values can come from 192 and can go up to 223, not more than that, because that's the range. But in the second network block, the value can go from 0 to 255. But if we see here, the number of networks definitely increased here, but
Yep.
the IP address is decreased. Okay. So number of network is telling you number of network blocks, and by checking whether they are of same or not, it is telling you that whether they are part of same room or not. You can say like if two people are there in room number 21, two people are there in room number 24, two are there in room number 10, and two in room number 2. So if they want to communicate with each other, they are in the same room, they can communicate, no issues there. And if I want to identify, I only know that there are two persons in room number 21. So I'm identifying them by what? Their room number, not by their names. Their name will come later, because it could be possible that in room number 21, the person's name is Karam and Lucky.
Yep.
And it is possible for those two names to be available in this network too. So if I only say that Karam and Lucky can communicate with each other, it might be possible that in the room number 10, Karam is here, but Lucky is not there. Instead of Lucky, Shahrukh is there.
Yep.
And in the last one, Lucky and Shahrukh is there. So if I, in general, I say that Shahrukh and Lucky can communicate. So I only know that these two are available in this case. So only one scenario is true. But if I say Karam and Lucky can communicate, multiple scenarios will be created. So I need to specify that Karam and Lucky in room number 21 can communicate.
Yep.
So the IP addressing too, what we are doing is the same thing. Here, first of all, we are checking the subnet mask of that, or by using that, we are checking how many network blocks are available. And depending on that, we are checking whether the network block are similar or not.
Yep.
Once we got the number of the network blocks, then we can check the class of that IP address. Uh, when we see here in the first case, it is starting from 10 and there is only a single network block. So
Yep.
which class it is which have a single network block and the range is 10. So only here it is. Class A have the 10 included somewhere in between, and it only consists of a single network block.
Okay.
So this is the IP address of class A. But if we see the second one, in this, how many network blocks are there? Two network blocks. So we need to check these two values. So they are same, they can communicate. But if we talk about their class, do we have any class which have two network blocks and starts from 10?
No.
No, we don't. So this IP address will be called classless IP addressing. We are not using classes there. And in that classless IP addressing, we will be seeing the subnetting part. Okay. So what we discussed today is just the basic of IP address, like what IP actually is, IPv4 classes, and how can you identify whether they can communicate or not. Okay. And okay.
Yep.
So any doubts in normal IP addressing? What IP addressing actually is? Go through the
Yeah.
recording again.
Yeah. We'll go through the lecture again.
Yeah. So
Yeah.
if you have any doubts in this after that, we'll discuss that first. Otherwise, we'll move on to the next one, that is our subnetting. I'll just give you a basic example what we will be doing in subnetting here. Like these rooms that we created. What we will be doing in subnetting, we will be creating multiple parts in those rooms. So you can say we will be dividing those bigger rooms into much smaller rooms.
Yep.
So now, before there was only a single room, room number 9, but after subnetting, it will be like 9A, 9B, 9C, 9D.
So the subnet mask is only there because when we can't identify IP address depending on what network class they are. That's
Yes,
why
that's why we will check whether they are of same network or not, whether they are part of same room or not. If they are part of same room, they will be able to communicate. Otherwise, they won't be.
Yep.
Okay. Okay, so let's continue tomorrow with the
Yep.
subnetting part.
Yep.
Okay.
All right. No worries. Thank you.
Okay, welcome.
You have a good day.
Yeah, same to you.
All right. You're not seems well.
Yeah, yesterday I was traveling and just
So
caught
are
a
you
course.
still teaching from home, or are you at the institution?
No, I just got back home yesterday
Oh,
because
okay.
of
Okay.
this health.
Okay. Yeah. All right. All right. Take care of yourself, and I'll see you tomorrow.
Yeah, sure.
Thank you.
Okay, welcome.
Bye.